Hello friends, you are now going to see what is common between all these pictures. Can you see these petals? Can you see Mona Lisa's painting? All this has got something to do with the mathematical number 1.6. That is called as the golden ratio. This ratio occurs in all these logos. The Apple logo. It occurs in a spiral, as you can see. I'm now going to explain to you the Fibonacci series. Get ready. Hello friends, today I'm going to explain to you the Fibonacci sequence. Now what is the Fibonacci sequence? Let us see if we have numbers like this. Say I start with a 1 and another 1. Now add these two numbers and put it here. So 1 plus 1 becomes 2. The next becomes this 1 plus this 2 becomes 3. 2 plus 3, 5. 3 plus 5, 8. 13. 8 plus 13, 21. What is the next number? Come on. Yes, 34, 55, 89, and so on. So this one is something like this, that the nth term is nothing but the n minus 1th term plus the n minus 2th term. This is the formula for the Fibonacci sequence. Now this is a very interesting sequence in mathematics. Now this was discovered by an Italian mathematician whose name was, yes, Fibonacci. And somewhere in the 12th century, to be precise, this is the time where he lived. He was born in a town in Italy, a town called Pisa in Italy. Now what is special about this sequence? Many things in nature follow this sequence. I'm going to explain to you how it works. For example, you take the formation of petals, the formation of tree branches, the formation of spirals in a shell or something like that. They all follow this strange pattern. Let me show you first the example with a tree. I want you to observe how the branches of this tree is developing. You can see that it starts here with one single, then again it develops to a 1, again it just grows, then slowly it splits into two parts. Can you see that? Here you are getting a 2. Then 1 plus 2, 3. So here you see there are 3. 1, 2 and 3. Can you see how it is developing? Let's go to the next one. Now you have 2 and 3. You add these two. So this is 5. So you have 1, 2, 3, 4, 5. So you start with 1, 1, then 2, 3, 5. And naturally the next is going to be how much? 3 plus 5 becomes 8. And this sequence goes on and on. So this is how it is found in nature. There is also the shell development called as the Nautilus shell. Let me show it to you on the next page. I want you to observe this spiral. You can see the spiral here developing. This spiral, any spirals are developed by using the Fibonacci spiral. I wanted to see how the spiral develops. This is also a Fibonacci series. Imagine you start with this triangle here, or rather this square of 1 by 1, 1, 1. This is also 1, 1. So naturally this big spiral, this big rectangle, this is going to become 2. So 1 plus 1 becomes 2. Now this is 2 units, so 1 and 2 becomes 3. So this one will be of 3 units. Now 3 and 2, so this is now 5 by 5. And 5 and 3, 8 by 8. Now when you draw arc on this, I'll show it in a different color, say green. See this spiral developing? So you're drawing something like an arc here, and continue doing the same, and you're going to get a perfect spiral. So the equation of a spiral, or how spirals are developed, this usually occurs in shells. Also the petal formation. You check all the plants or all the flowers. The number of petals they have also follows the Fibonacci series. Observe that you can either have one petal, or 3 petals, or 5 petals, 8 petals, 13 petals. All these are actually the Fibonacci sequence occurring in nature. Now when you develop the series like this, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. As you keep on dividing this number, say 89 divided by 55, it goes on and on like this. So you divide the last number with the second last number. Now this ratio approaches to something like 1.6. This is called as the golden ratio. The ancient Greeks considered a line segment to be divided into a golden ratio if the ratio of the shorter part to the longer part is the same as the ratio of the longer part to the whole segment. What does that mean? Imagine you have a line like this. Say for example, this is 1 unit, this is x unit. So 1 shorter by the longer part, 1 by x is equal to the longer part upon the whole ratio. So this ratio, the value of x here, if you calculate using the quadratic equation, you will get x as 1.618. Now this occurs in many cases. The ancient Greeks agreed with this and built their temples in this ratio. The golden ratio is related to the Fibonacci numbers, because when you keep on taking the higher number and divide it with the preceding number, you will always get the same ratio. It will tend to this ratio. So there is considered to be a lot of beauty in this. Many of the logos are designed using this ratio, 1.618. So when you're drawing a rectangle or something like that, you will see that many of these are designed as per this ratio. For example, take the logo of Apple. This also follows a spiral. Many photographers use this same idea. If you take this length and divide by this length, it is the same golden ratio. You will get 1.618. 1.618 occurs even in the photograph of, or rather the painting of Mona Lisa. So that is why it is called as a golden ratio. So this is a small introduction I gave you on the Fibonacci series. You can read more about it on the internet, and it's a very, very interesting thing how people used to use this ratio. Thank you.